Newton invented the calculus in order to solve physics. And the physics I want to talk about in this video is the motion of a mass. So we can specify the position of the mass in one dimension here. So we're just looking along a line. We can specify the velocity of the mass. The velocity of the mass is the speed of the mass, including the direction. So a positive velocity means the mass is moving to the right, and a negative velocity means the mass is moving to the left. The acceleration then is how much the velocity is changing. So a positive acceleration means the velocity is becoming more and more larger and larger on the positive side. Okay, so how do we use calculus to define velocity and acceleration? We start with the position. So the position of the mass then, we'll write that as a function of time. And then to define the velocity, which will also be a function of time, we define it through the derivative, which is the derivative of x with respect to time, dx dt. So that's the definition of the instantaneous velocity. So it's the change of x divided by the change of time. And in Newton's notation, that was written as x with a dot on the top. So this is a physics notation that goes all the way back to Newton, and we represent the derivative as a dot only if it's the derivative with respect to time. For the acceleration, we can use the symbol a. That's also a function of time. That's the derivative of the velocity with respect to time. But the velocity is the derivative of the position, so that's the second derivative of the position, d squared x dt squared. And in Newton's notation, that was written as x double dot. Okay. We have Newton's law, Newton's second law. That's the most famous one. That's, you may know, is F equals ma. F equals ma. But now we have the calculus to define a, so we can write that as an equation for the acceleration. So Newton's second law then becomes x double dot, which is a, the acceleration, is equal to the force applied to the mass divided by the mass, m. So this is called a differential equation. It's a second order equation, it's a second order differential equation for the position x, if you know what the force on the mass is. Okay, one more thing I would like to talk about. Sometimes we know that the velocity, rather than being a function of time, is a function of position, right? And then the mass is moving, so the position of the mass is a function of time. So if we want to compute the acceleration here, we can use the acceleration is dv dt, but v is a function of x, so we can use the chain rule here. So it's dv dx times dx dt from the chain rule. But dx dt is just the velocity. So sometimes it's useful when you're doing physics that you can write the acceleration as the velocity times the derivative of the velocity with respect to x. I use this result in my differential equations course. So let me summarize. Newton invented the calculus to do physics. Basic to physics is being able to compute the position of the mass, the velocity of the mass, and the acceleration of the mass. The acceleration of the mass from the equation F equals ma gives us a differential equation, which is x double dot equals F over m. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.